All right, hi. This is section 10.3, two-way tables and probability. I'm going to do 1, 2, 3, 4, 5 examples, so get excited. Number 1 says there are 16 juniors and 24 seniors on a debate team. Of these, 7 juniors and 19 seniors qualify for the state debate competition. Organize this information in a two-way table, and then find and interpret the marginal frequencies. Okay, so looking at the information that we're given, we know that there are 16 juniors and there are 24 seniors. And of these, 7 juniors and 19 seniors qualify. So of the ones that qualify, 7 of them are juniors and 19 of them are seniors. So basically, we have to fill in what we don't know. Well, there's a lot of stuff that we don't know. So if there's 16 juniors total and 7 of them qualify, that means that 9 of them did not qualify. And if there's 24 seniors and only 19 qualified, then that means that 5 did not qualify. Okay. And then now we have to add up all of the people that qualified. And 19 plus 7, that's 26. 9 plus 5 is 14. Okay, so then it asks you to find and interpret the marginal frequencies. And the marginal frequencies are anything that are in these rows. So this number right here is going to be the addition of this side or that side. And the cool thing about that is that it should always add up to be the same thing. And in this case, if you were to add them, you would get to 40. So now we had to describe what each of these boxes basically mean. So this one was one that they actually gave you. This is the number of juniors that we asked. This number here is the number of seniors that they asked. This number is the total number of people that were asked. This is the number that did not qualify. Okay. And this number right here is the total number of people that did qualify. Okay. And all that, when it says find and interpret, it's just basically telling me what do those numbers mean. Okay. A lot of this section is just being able to read a table. Can you read a table? Which is a really great skill to have for the ACT and the EOC. Okay. Hopefully that's not super confusing yet. Number 2 says use the information from number 1 to make a two-way table that shows the joint and marginal relative frequencies. Okay, well, so we know that there are 40 people total, and so we want to find out. Basically what this table is telling you is what's the probability that you're a junior who qualifies. Okay, so well, we know that there's 7 people that are juniors and that qualify, and there's 40 people that were asked total. And so then if we turn that into a decimal, that creates 0.175. So now this box is asking you, okay, what's the probability that you're a junior who did not qualify? Well, there's 9 of those people out of the 40 people that were asked, and that's approximately 0.225, okay? And then there's a couple different ways that you can think about that last column there. You can think, oh, well, that should make sense that then the total would be 16 over 40, which is approximately 0.4, or you could have just added 0.175 plus 0.225, added these numbers across, and you would get the same answer. So however that you want to think about that, that is basically saying that tells you that basically they're 40% of the people that you asked are juniors. Okay, that's all that means. So now it's asking you what's the probability that you're a senior who qualifies? So there's 19 of you out of 40, which is approximately 0.475. That did not qualify. There were 5 of those out of 40, and so that's approximately 0.125. On this total over here, you can either add them up or you can take 24 out of 40, and that means that 60% of the people that you asked were seniors. Okay, and the really cool thing about this question is that this box down here should always add to 1. Okay, so 0.6 plus 0.4 does add to 1, so that means we did it right. And then to find these right here, that just means we need to add these probabilities straight down. So 0.175 plus 0.475 is equal to 0.65. that means that 65% of the people that you asked qualified. And so then you've got 0.225 plus 0.125, which is 0.35, which should make sense. If 65% of the people that you asked qualified, then that means that 35% of the people did not. Okay? So, yeah, hopefully that makes sense. Okay, that's what marginal relative frequencies are. On number 3 here, it says use the information from number 1 to make a two-way table that shows conditional relative frequencies. Okay, so marginal relative frequencies and conditional relative frequencies are different things. Okay, and it says based on the row totals. So that means that we're only interested in juniors and seniors, and we're not going to really cross paths here a whole lot. Okay, so what this table is basically asking you is what's the probability that if they're a junior, so if they're a junior, well, there was a 40% chance that they were a junior. So if they're a junior, that they will qualify. Well, the probability that they qualified was 0.175. So if you take that, you get 0.438%. So then it's asking you, okay, well, if they're a junior, what's the probability that they did not qualify? And that's 0.225, and that's equal to 0.563. This is asking you, okay, well, if they're a senior, and in this case there was a 0.6% chance that they were a senior, then that means, or the probability that they qualified was 0.475, which equals 0.792. So there's a 79.2% chance that if you're a senior, you qualified. And then if you take the probability that they did not qualify, which is 0.125 divided by 0.6, then you would get 0.208. Okay. So that's conditional. Remember, conditional meant that there was an if statement. Something had already happened. And so I'm asking you, because it was a row total, it's basically saying if you were a junior, then what was the percent that you qualified? And if you were a senior, then what was the probability that you qualified or didn't qualify? So basically make sure that you understand that it said row total and not column total, because if it said column total, then that would have been, okay, if you qualified, what's the probability you're a junior? And that's not what it asked. So be very careful with the wording there. Okay. On to the next one. A store surveys customers of different ages. The survey asks whether they would like to see the store expand its toy department. The results given as joint relative frequencies are shown in this two-way table here. Okay, so I've already given you the joint relative frequencies. That is what we found here. Okay. What's the probability that a randomly selected customer whose age is between 10 and 20? Okay. So yeah. So it's asking you what's the probability that a randomly selected customer whose age is in between 10 and 20. Okay, so we are only interested in the people whose age is between 10 and 20 years old. That's these two right here. Okay, so out of those people, so 0.06, because we care about both groups there, 0.06 plus 0.17, that's equal to 0.23. So out of all of the people in between ages 10 and 20, would not like to see the toy department. So the people that answered no were 0.17. So if you plug that into the calculator, you get about 73.9%. Okay, so that means that if you were in between the ages of 10 and 20, there's a 73.9% chance that you said no. Okay. Part B says, what's the probability that a randomly selected customer, so a randomly selected customer, so any age whatsoever, okay, who would like to see the toy department expand. So any age, but would like to see it expand. So that's all of the yeses. The only people we care about are the yeses. So that's 0.27 plus 0.06 plus 0.23. So that equals 0.56. And then we're interested in the ones that are younger than 10 and 0.27 or younger than 10. And so that is approximately 48.2%. So that means that if you would like to see the toy department expand, there's a 48.2% chance that you were younger than 10, which should make sense. Kids love toys. Okay, so that's nice. It says determine whether replying yes, so we'll call that event A, and being younger than 10, we'll call that event B, are independent events. Okay, so let's look at probability of A. The probability of A is determine whether if we replied yes. Okay, so I need to know all of the cases in which we could reply yes, which is this row up there. So the probability that we replied yes is 0.27 plus 0.06 plus 0.23, which is equal to 0.56. Okay? The probability then that we're younger than 10 is a probability that we said yes and we were under 10, and the probability that we said no and we're under 10. So that's equal to 0.27 plus 0.09, okay? And that's equal to 0.36, okay? And so we know that the probability of A and B occurring, which basically means that we replied yes and we were 10 years old, that's this column or that box only, which is 0.27. And if we were independent, then that means that this times this was equal to that. And so we have to take 0.56, multiply it by 0.36, okay? And that is equal to 0.2016, which is not equal to 0.27. So no, they're dependent, which should make sense to you. It should make sense here that your age is going to determine whether or not you want a toy store built. Okay, obviously kids are not going to want like a clothing store built over a toy store. So just keep in mind that that's going to happen. Okay, keep in mind the situation. All right, number 5. An airline company strives not to lose luggage for passengers. Well, that's good. A manager at the company randomly selects 3 flights to check on lost luggage. At the end of each day, the manager determines whether or not there was luggage lost on the flight that day. The table shows the findings. Which flight does the best at not losing luggage? Okay. So remember how this is not completely, you can't basically tell whether or not it's true by looking at the table necessarily. You actually have to do some math because there's different, like on flight 1, 2, and 3, a different number of people were asked. There were different numbers on that flight, so you can't compare them like that. You actually have to do some math here. So I'm going to set up another table. This is flight 1, 2, and 3, okay? And I'm going to find the probability that we lost the luggage and that we did not lose the luggage, okay? So if I make my handy-dandy makeshift table here, okay, there are 5, 10, 15, 20, 25, 30, 33, 37, 38, 39, 40 total people that were asked, okay, and 10 of them, so 10 out of 40 said they lost their luggage on flight 1, which is 25.25. And there were 3 out of 40 who said they did not lose their luggage, which is 0.075, okay? So that basically means that 0.25 plus 0.75, that means that 0.325% of the people that were asked, or 32.5% of the people that were asked were from flight 1. Flight 2 had 9 out of the 40 lose their luggage, and that's 0.225. And that means that 5 out of the 40, which is equal to 0.125, did not lose their luggage. And if you add those up, then 35% of the people that we questioned were from flight 2. Okay. And on number 3, 12 out of the 40 lost their luggage, which is equal to 0.30. 1 out of the 40 people, which is 0.025, did not lose their luggage. If you add those up, then 0.325 is your answer. So that's 32.5% of the people on the flight, or that we asked, were on flight 3. Okay. So now let's find these frequencies down here. If you add up those 3 numbers, that's 0.775. So that means that 77.5% of the people lost their luggage. Oh, geez, this is a very terrible airline here. And so if you add up all of those, then that means that 0.775 225, so 22.5% of the people then did not lose their luggage. I don't like those odds. So now we want to know which one's the best. Okay, and remember we can't compare because we have different numbers of people asked on these flights. So basically we want to look at what's the probability that we were on flight 1 and we did not lose the luggage. Okay, so that means that we were on flight 1, we did not lose our luggage, so that's 0.75 out of, well, of all the people on flight 1, that's 0.325. And if you work that out, that's about 23%. So that basically means if you're on flight 1, there's a 23% chance that we are not going to lose your luggage. Okay. The probability of being on flight 2 and not losing the luggage, I'll abbreviate. Well, there's 35% chance that we were on flight 2 in the first place and that we didn't lose was 0.125. And if you divide that out, then there's a 36% chance that if you're on flight 1, you're not going to get your luggage lost. So sorry, kids. And the probability that if you're on flight 3 and you don't lose your luggage, again, notation isn't super important as long as you get the right answer. There was a 0.325 chance that you were on flight 3 and 0.025 that you didn't lose your luggage. So then that is equal to 8%. Oh, that stinks. So then basically the table shows the findings. Which flight does the best at not losing luggage? Well, then we're looking at our highest percentage there, and that's flight 2. I personally wouldn't fly on any of these flights. I would find a new airline because I like my bags. Okay. Hopefully that helps. I know that some of this can be kind of confusing in the wording, so if you have any other questions, just come see me. Thanks for watching.